Hello, it's dumplet here. Here's an item on geometry. We have two regular polygons, a hexagon and a square. Which figure has a bigger perimeter? Now credits to the assistant in German Academy for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Right, so now that you guys have an answer, maybe it's the square, maybe it's the hexagon, maybe they have the same perimeter. Let's try to figure things out here. All right, the thing to notice is that there's no really side lengths given, so it's all right. We can always, without lots of generality, just let something here, because we know that we can scale things up, scale things down. So just to simplify our calculations, let's just say that the side length of this regular hexagon, let's just say it's 1 for now. Let's just say the side length is 1. And with this, we can try to make some observations, and hopefully we get the side length of the square, and we can get the perimeters that way. So the first thing to notice is that I think this triangle over here, the common region of the two, I think we can focus on this triangle because, well, if I can manage to get this angle in between, like this part, this red angle over here, I think is a very standard case of the cosine law, because I have two sides here with length 1. If I can manage to get this one, then we can use the cosine law to help us get the side of the square. So there might be different approaches, but in my opinion, that's going to be like the fastest way to do this item. So let's try to discuss this angle, because it is just an interior angle of a regular hexagon, and we do have a nice formula for that. It's the 180 times n minus 2 divided by n. Now, this numerator might be familiar to some. It's the sum of the angles in a regular in an n-sided polygon. And if it's regular, then all the angles are the same. So if you want to get like just one of the angles, we have to divide it by n. So this is going to be the formula for one angle inside a regular polygon with n sides. Now, since we have a hexagon, so that 120 over here, that's the result of this. So 180 times 6 minus 2 divided by 6. Now the numerator here is going to be 720, and 720 divided by 6, that's going to give us the 120 over here. And now that we have the angle in between, I think what we have to do is let's just say this is x for now, the side of the square, and we can use cosine law to help us get the side of the square. So by cosine law, we'll have x squared equals 1 squared plus 1 squared minus 2 times 1 times 1 times cosine of 120 degrees. And luckily for us, 120 degrees is one of those special angles, so cosine 120 is a pretty nice value of -1/2. So there we go. All we have to do now is just to solve for x. So let's simplify the right side a little bit. So we have x squared. That's going to be equal to 1 plus 1, minus 2 times 1 times 1 times -1/2. So let's try to see things here. If this thing was -1/2, then these two negative signs make this a positive sign, and then we have a 2 and 2 here that cancel. So apparently this third number over here is just 1. So x squared is 1 plus 1 plus 1, and that's 3 1. So obviously that's just going to be equal to 3. So from here, I would be able to get that x, which is simply the square root of 3. Again, positive, negative, technically, but since we're just talking about distances here, we're just going to take the positive root. So x here would be equal to square root of 3. And there we have it. We have the side of a regular hexagon, which is 1, and we have the side of the square. So in this case, it's the square root of 3. Now from this, we can make a nice observation, is that we have the ratio of the sides. So if the side of a regular hexagon is 1, the side of a square is apparently square root of 3. So if you try to assign other lengths, you're going to realize that the ratio of the side of a hexagon to the side of the square, it's going to be 1 is to square root of 3. So that's one thing you can try to verify it on your own. Anyway, so for the context of the question, we now have a perimeter. So we now have the sides of the square and the hexagon. So let's start with the square first. So it's just 4s, so 4 times the side. So I think for the square, the perimeter is going to be 4 times the square root of 3. so that's just 4 square root of 3. And for the hexagon, we have a side of 1, and it has 6 sides, so 6 times s, so 6 times 1, that's just going to give us 6. Now, some of you guys may know that square root of 3 is approximately 1.7. So 4 times 1.7, that's approximately 6.8. So we can easily arrive at the conclusion that it is going to be the square that is going to have a bigger perimeter. But we can try to view this a little bit, view this in a different way, because, well, maybe not all of you guys know that the square root of 3 is 1.7. So here's a nice solution for that. We can try to put these two numbers inside one square root, because, for example, if I were to compare which is bigger, the square root of 10 or the square root of 9, obviously it's going to be the square root of 10, because 10 is greater than 9. So we can do this method over here. So the 4 square root of 3, it's actually equal to square root of 3 times 4 squared. So you kind of put the 4 inside the square root, so it becomes 4 squared, and it's actually equal to the square root of 48. And then 6, we know we can just square 6, so that's 36. So that's going to be the square root of 36. So this can be one way to show us that, the square has a perimeter of square root of 48. The hexagon has a perimeter of square root of 36. Now 48 is greater than 36. So again, it is going to be the square that has a bigger perimeter. So just two ways to kind of verify our answer. But for the final answer of the question, obviously, it is going to be the square that has a bigger perimeter. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!